in question number 1, we have triangle LMN, and they tell us that angle M is 90 degrees. They tell us that MN is 12, and that LM is 16. And we need the ratio of secant of angle N. So we're focusing on angle N, and secant is the reciprocal of cosine. So it's 1 over cosine, which is the same thing as taking cosine and flipping it over. That's what the reciprocal is. So cosine of angle N is adjacent over hypotenuse. Now, I don't know what the hypotenuse is, so I can find it using the Pythagorean theorem. I can do 12 squared plus 16 squared is equal to c squared. Using my calculator, I'm going to type in 12 squared plus 16 squared, and I get 400. So c is equal to 20 if we take the square root of both sides. So adjacent over hypotenuse is 12 over 20. And if I flip that over to find secant of angle N would be 20 over 12. And that's answer choice number 1. Moving on to number 2. In triangle ABC, angle C is the 90-degree angle. AB is 29 and AC is 20. And we need to find which statement is not true. The first answer choice has a focus angle of angle A, and it's talking about cosine. Cosine focused at angle A would be adjacent over hypotenuse, which would be 20 over 29. That is true, so that's not the choice we're looking for. Answer choice 2 is talking about angle B, and it's once again talking about cosine. From angle B, here would be adjacent, and here would be the hypotenuse. I don't know what the adjacent is, so I'm going to have to find it. I'm going to use the Pythagorean theorem, 20 squared plus b squared equals to 29 squared, because 29 is the hypotenuse. 20 squared is 400. 29 squared is 841. If I subtract 400 and I take the square root, I have the missing side length is 21. So from angle B, adjacent over hypotenuse would be 21 over 29. So that is true. So that's not the one we're looking for. So I'm going to reset, and I'm going to cross that out. From angle A, we're talking about sine. Sine is opposite over hypotenuse. That is true. 21 over 29 is opposite from angle A over hypotenuse. And finally, tangent of angle B, opposite over adjacent. So that would be 20 over 21. So here, these are all true. So I'm going to edit this one. I'm going to flip it over. I'm going to make it 21 over 20. And now it's not true. And I'm going to circle that answer choice. And I'm going to make that edit on the review sheet. For question number 3, in the right triangle ADE, BC is parallel to DE. So the small triangle and the big triangle are similar triangles because they have congruent right angles, because those are corresponding angles created when parallel lines are cut by a transversal, and they have the shared angle A. So the smaller triangle and the bigger triangle are similar to each other. And it's asking us which ratio is equivalent to the sine of A. So there's 2 possibilities that could work. There's the sine of angle A from the small triangle, and there's the sine of angle A from the big triangle ADE. Now, from angle A, Opposite would be BC. So I'm going to write sine of angle A would be BC. That's opposite over hypotenuse, which is AB. And from the corresponding angle A on the similar triangle, sine of angle A would be opposite, which is DE, over hypotenuse, which is AD. And I see that that is answer choice number 1. In number 4, we have right triangle ABC, and angle A is 32 degrees, angle B is 90 degrees, and AC is 6.2 centimeters. We need to find the length of BC. So let's do it. This is our focus angle. Let's label opposite, adjacent, and hypotenuse. So what we need, and we can write down SO Kachoa on our paper to help us remember, but we need O and H, and that's going to be sine. So sine of the 32-degree angle is equal to opposite over hypotenuse. From here, we can put over 1, and we can cross multiply. So we have 6.2 sine of 32 is equal to x. If I put that into my calculator, 6.2 sine of 32, and I round to the nearest tenth, I have x as approximately 3.3. And that's answer choice number 2. In the next one, I have a bunch of triangles. I have the 2 smaller triangles, and I have the big triangle. And I'm told that the triangles are similar to each other, but in fact, all 3 triangles are similar to each other. Because what we have here is a big right triangle with 2 smaller right triangles on the inside. So what I'm going to do is I'm just going to redraw the right triangles so they're facing the same way. And I know that the 2 right triangles I'm interested in are triangle CDB and triangle ADB, the 2 smaller ones. I'm going to label it triangle 1 and triangle 2. But since they're both inside of the bigger triangle, my best option is to just redraw all 3 of the triangles so I can make sure that the corresponding parts match up. So here's the biggest triangle, and I'm just going to put the right angle here, and it doesn't matter where I put A and C for now. I'm just going to make it match up in the smaller ones. So this is going to be triangle 1. I'm going to put a 1 in here, and that's one of the ones that we're focusing on. That's ADB. The right angle is at D. This triangle is inside of the big right triangle, so it's got a shared angle with the big right triangle. The shared angle is angle A. Notice how angle A is inside of this triangle, and at the same time, angle A is also inside this triangle. So if I put angle A over here in the big right triangle, I also have to put angle A here in the small right triangle. And that leaves B to be over here. And now, one more triangle, triangle 2. The right angle is at D again. This triangle is also inside the big right triangle, so that means it shares an angle with the big right triangle, and that shared angle is angle C. Notice how angle C is inside of the smaller right triangle, and at the same time, it's inside of the bigger right triangle. So that means angle C needs to match up with angle C in the big triangle. So I need to put them in the same spots. And then that leaves angle B to be over here. I redrew all of the triangles so that the corresponding parts were in order. Yes, you do have the triangle name, so you can use the letters as well. But I did want to do the long way, because if you weren't given the triangle letters, I do want to show you guys how to figure out what corresponds to what in the different triangles. In fact, these letters are not with the corresponding parts in order, because as we see here, angle C in this triangle should match up to angle B in this triangle. So redrawing the triangles is always the safest way to do it. Now we know for sure what corresponds to what. So BC is 18 and DC is 12. And we need the measure of angle A to the nearest degree. Now, the great thing about having our similar triangles drawn with the corresponding parts in order is that angle A in this triangle corresponds to angle A in this triangle, and that corresponds to angle B in this triangle. So when we have similar triangles, remember the corresponding angles are all congruent. So finding the measurement of these angle A's is the same thing as finding the measurement of this angle B. So if we find the measurement of this angle B, we have the measurement of angle A, and we are all good to go. So let's set up a trig ratio for angle B. This is opposite. This is the hypotenuse, so that's going to be sine. Sine, of the angle that we're looking for, which is angle A, or in this case, angle B. So I'm going to just write that as angle B, so we're not confused, is equal to opposite over hypotenuse. Now, if I take the inverse sine of our sine ratio, then I will get the angle that made that ratio in the first place. And it does say the round to the nearest degree. So I'm going to type in second sine, 12 over 18. And I got approximately 42 degrees. So that means all of these angles in the same spot are 42 degrees. They are all similar triangles. Similar triangles have congruent corresponding angles and proportional sides. Okay. Here we're looking for, first, we have to find the value of x that will make sine and cosine equal. Sine and cosine are cofunctions, so that means that they're equal when their angles add to 90 degrees. So I need to take the angle from the sine and the angle from the cosine and make an equation that says if I add them together and equal them to 90, well, that's going to give me the value of x that makes sine and cosine equal. That's when their angles are going to be complementary. So we have 4x plus 4 is equal to 90. I'm going to subtract 4 from 90, and then I'm going to divide by 4. And I have that x is equal to 21.5. Now it's asking for the value of the smaller angle, so I got to find both of them to compare. So 3x plus 6 is 70.5 degrees. And x minus 2 is 21.5 minus 2. And 21.5 minus 2 is 19.5. So the 19.5 degree angle is the smaller angle. Moving on to number 7. What is the perimeter of an equilateral triangle whose height is 2 radical 3? So I have an equilateral triangle. Height means altitude, so I have the altitude. And this height is 2 radical 3. If we have an equilateral triangle, the sides and angles are all equal, so the angles all measure 60 degrees. And when we have an equilateral triangle, something really nice happens with the altitude. It also divides the angle equally. So what we have are two 30, 60, 90 triangles here. And our ratio for the sides of 30, 60, 90 triangles is 1 to radical 3 to 2. We have the 2 radical 3, which is across from the 60-degree angle, which is the middle biggest angle. So we have the middle biggest side, which is the 2, which is the radical 3 part of the ratio. To find the perimeter, we need all of the sides. So let's start off with finding the smallest side, which would be opposite from the smallest angle. In order to get from the middle biggest side to the smallest side, we're going from bigger to smaller, so we're going to be dividing. And the ratio tells us that we're going to divide by radical 3. So I'm going to take our middle biggest side, and I'm going to divide by radical 3. Simple enough. But wait, we can't have a radical in the denominator. So I'm going to rationalize it. I'm going to multiply the top and the bottom by radical 3. Radical 3 times radical 3 is just 3, because it's radical 9, which simplifies to 3. So what we have really here is 2 times 3, which is 6. Radical 3 times radical 3, once again, is radical 9, which is just 3. So what we have is that this side over here is simply just 2. And yes, you might have noticed top and bottom, they cancel. You can cancel that out. But I did it the long way. And now that we have the short side, super simple to find the longest side, because from the smallest side to the longest side, it's a 1 to 2 ratio. So all you have to do is double the shortest side. So if the shortest side is 2, that makes this 4. So this is also 4. This is 4. So this is 2, 4, 8, 12. 12 is the perimeter. Moving on to number 8. Lorena and Carla are creating an art project in the shape of a right triangle. They have a 92 centimeter long. Let me just verify that that's 92. Yes, 92. They have a 92 centimeter long piece of wood, which is used for the hypotenuse. The two legs of the triangular support are of equal length. Approximately how many more centimeters of wood do they need to complete the support? So since we have a right triangle and it's got 2 equal sides, that means it's also got 2 equal angles. So what that means is that we have 2 45-degree angles. So what we have is a 45, 45, 90 triangle. 45, 45, 90 triangles have sides that are in the ratio 1 to 1 to radical 2. 1 to 1 means 2 of the sides are the same length, and that makes sense because we have 2 equal angles, so that means 2 equal sides. And the hypotenuse is radical 2 times as large as the legs. Here, we have the 92, which is across from the 90-degree angle. So we have the biggest side, we have the hypotenuse. So we have the radical 2 part of the ratio. We need to figure out how much each of the legs are. So we're going from bigger to smaller, so that's going to be dividing. And the ratio tells us that we're going to divide by radical 2. So we're going to take 92 and divide by radical 2. Just like in the last one, we can't have a radical in the denominator. So I'm going to multiply the bottom and the top by radical 2. And here I have 92 radical 2 over 2. I can divide 92 and 2. They go evenly. So what I have is 46 radical 2. So that's the length of each of the sides. So Lorena and Carla already have this 92, but they need this and this. So they need 2 46 radical 2s. So I'm going to type in 46 radical 2 into my calculator, and I'm going to multiply it by 2. And I'm going to write it over here too, 46 radical 2 times 2. And they need approximately 130 pieces of wood. It doesn't specify how to round, but we're going to round to whole pieces of wood. Moving down here to number 9. As modeled below, a projector mounted on a ceiling is 3.74 meters from a wall where a whiteboard is displayed. The vertical distance from the ceiling to the top of the whiteboard is 0.41 of a meter, and the height of the whiteboard is 1.17 meters. Determine and state the projection angle theta to the nearest tenth of a degree. Now, I'm finding angle theta, but if you take a look, the triangle that angle theta is part of doesn't have a right angle. So we don't know it's a right triangle, so we can't directly use a trig ratio on it. So I'm going to look for right triangles. I have this small right triangle over here, this one. And I also have this big right triangle over here. So what I'm going to do is I'm going to use the big triangle to find the big angle, the big right triangle, I should specify. I'm going to use the small right triangle to find the small angle because that's part of the small right triangle. And then once I find those two, I can subtract and get the one that we're looking for. Let's start with the big right triangle. So our focus angle has to be the angle that we're, the ones that we're looking for. So for the big right triangle, we're going to find the green angle. Opposite in the big right triangle would be 0.41 plus 1.17, because if I'm using an angle from the big triangle, I have to use the full side from the big triangle as well. So opposite would be 1.58 for the big right triangle. And we have adjacent. We don't know anything about the hypotenuse, so that's tangent. So I'm going to label here, this is for the big right triangle, tangent of, and I should just probably switch the colors here so that it matches up to what we're finding. I'll use red for the big angle, then I'll use green later on for the small angle, and I'll just call that x. So we have a variable is equal to opposite over adjacent. And then we're finding an angle, so we're going to use inverse. And when I stick this into my calculator, this is not the final answer. This is not what the question is asking me for. So I don't want to round early because that can impact the answer, and it often does. They often pick numbers on the Regents exam purposely that if you round early, you'll end up with the incorrect answer. So what I'm going to do is I'm going to keep a few decimal places until my very last step, so I don't make the mistake of rounding early. Now let's find the angle from the small right triangle. So I'm going to call that y. So we have tangent of angle y is equal to opposite. In the small right triangle, that would just be the side from the small triangle, the opposite side from the small triangle. So that would be 0.41 over adjacent. The adjacent side in both of the triangles is the same. That is 3.74. And we can use our inverse tangent in order to figure out what the angle is. And this is not my final answer. So once again, I'm going to keep a couple of decimal places after I put this into my calculator. And it's approximately 6.2561. And now that we have the big angle and the smaller angle, we can subtract them. And when we subtract them, we find that theta, let me just subtract them real quick from my calculator, is approximately, to the nearest tenth of a degree, 16.6 degrees. Moving on. From an airplane, I'm not a good artist. It looks like a fish in the sky or a piece of bread with wings. From an airplane at an altitude of 1,200 meters, remember, an altitude's a height, so that's how high up in the sky the airplane is. The angle of depression to a rock on the ground measures 28 degrees. If I was in the airplane looking down on the rock, the angle of depression would be the angle at which I'm looking down at the rock at. So remember, your angle of depression is always outside of the right triangle. And remember that it is alternate interior with the angle of elevation. We need to find the distance from the plane to the rock. So we're looking for this side over here. Now that I have my focus angle inside of the right triangle, we have opposite. We're looking for hypotenuse. So I'm going to be using sine. Sine of the 28-degree angle is equal to opposite over hypotenuse. Let's cross multiply because we're solving for a side. X sine of 28 is equal to 1200. If we divide both sides by sine of 28, we have that x is approximately, and the question should specify how to round, but it doesn't. So I'm going to round to the nearest tenth. And on the test and on a Regents exam, it will specify how to round. And that is approximately 2,556.1 meters. Moving on. The map of a campground is shown below. Campsite C, first aid station F, and supply station S. It's really nice when they use the letters that actually represent what the stuff is. It makes it easier to figure out. And they lay along a straight path. That's important because here they are. The path from the supply tower T is perpendicular to the path from the supply station to the campsite. And that's why we have that 90-degree angle here. So we have right triangles. The length of path FS is 400 feet. And nice, that's already labeled for us. The angle formed by path TF and path FS is 72 degrees. Once again, already labeled, nice. And the angle formed by path TC and path CS is 55 degrees, labeled already again. Nice. I'm going to state the nearest foot, the distance from the campsite to the tower. Now notice, this triangle over here is not a right triangle. In fact, you can find this angle. These are supplementary. This is not a 90-degree angle. We do have two right triangles here, but it's not this one. It's the small one over here and this large one over here, the whole big right triangle. Now, you might want to use the whole big right triangle because the big right triangle has x as its side. The problem is you don't know this side and you don't know this full side. So our plan of attack here is we're going to use the small right triangle. We're going to find another side of the small right triangle because we already have one of its sides. And we're going to find a side that's going to help us set up a trig ratio with the big right triangle. This side's not going to help because it's not part of the big right triangle. It's part of this non-right triangle over here. So this is going to be the helpful side. So I'm going to label this y. And we're going to find that first using the small right triangle. And once we have y, we'll be able to find x using the sides from the big right triangle. So for the small right triangle, here's my focus angle, here's opposite, and here's adjacent. So that's going to be tangent. So tangent of the 72-degree angle equals to opposite over adjacent. From here, we're going to cross multiply. 400 tangent of 72 equals to y. I'm going to put into my calculator, and once again, I am not going to round early. So I'm going to keep a couple of decimal places so my answer doesn't get impacted. And now I'm going to set up my trig ratio for the big right triangle. Now that I know another side from the big right triangle because this is the side. So now in the big right triangle, I have the 55-degree angle. Now I know the opposite side, and my goal is to find the hypotenuse. So that's going to be sine, opposite over hypotenuse. So sine of the 55-degree angle is equal to we could write this whole thing. We could write 400 tangent of 72 just to not be confusing. I'll write this whole opposite side. So that's 1231.0734 over the hypotenuse, which is x. Put this over 1, cross multiply. X sine of 55 degrees. And then from here, we can divide both sides by sine of 55 degrees to get x by itself. And when you put it into your calculator, please round according to the question. It says the nearest foot. So that means the nearest whole number. This is our final answer. So I got about 1,503 feet as my answer. One more question to go on this review sheet. Barry wants to find the height of a tree. So that's what he's looking for, the height of the tree. Angle C is a right angle. The angle of elevation from point A to the top of the tree is 40 degrees. And the angle of elevation from point B to the top of the tree is 80 degrees. The distance between points A and B is 85 degrees. Barry claims that triangle ABH is isosceles. Explain why Barry is correct. So in this triangle over here, we already have 80 and 90 degrees. So in my calculator, I'm going to do 80 plus 90, and I'm going to subtract from 180 degrees, and I get that over here, that's 10 degrees. These are supplementary, so this angle has to be 100 degrees. 100 plus 40 is 140, so this angle over here has to be 40 degrees. So in ABH, there are two congruent angles, the 40-degree angle and the 40-degree angle. And we know that if two angles of a triangle are congruent, the sides opposite those angles are also congruent. So once again, in a triangle, sides opposite congruent angles are congruent. Determine and state to the nearest foot the height of the tree. So now we have to find the value of x. I would like to use a trig ratio. If I take a look at the small right triangle, x is a side of it, but I don't have any of the two other sides. So we don't have enough information right away to set up this trig ratio because I don't know any of the sides. I can't use this triangle because it's not a right triangle, but I do also have the big right triangle here. And if I take a look at the big right triangle, actually, we do know another side of this triangle. Because remember in part A, we said that this triangle here, ABH, is isosceles with the two congruent sides. And one of the congruent sides is 85. So the other side is also 85. Now I can set up a trig ratio with the small right triangle directly. So from the 80-degree angle, we're looking for opposite, and 85 is the hypotenuse. So that's going to be sine. Sine of the 80-degree angle is equal to opposite over hypotenuse. I'm going to put this over 1. I'm going to cross multiply. And it does say our answer to the nearest foot. And that's approximately 84 feet. And that was the last question on the review sheet. Oh, let me go back down to it.